Hello and welcome to Smart Sheriff, Dumb Idea, the Wild West of Government-Assisted Parenting. So, in this talk, we are going to talk about an interesting law that was pushed in South Korea. And what basically happened is that, there was a law to protect the children. It's always like the reason to protect the children. So first we have to give you a little bit of background information, like how all this happened. And then we'll delve into what we looked at, which is we first looked at the main mandatory app, which was Smart Sheriff. Then after that, we looked at Smart Dream, which is another app, and then other similar apps from other mobile operators. And then at the end, we'll do some kind of conclusions and where do we go from here. So some takeaways from this talk could be some insight about South Korean culture and politics, some basics on Android reversing that we had to do for the test, and then the difficulties of the everlasting problem in security of disclosure. So I'm Abraham and he's Fabian. We work for Cure53. Some of our reports are public, so if you're the kind of person who likes reading pentest reports, you can go here and read them. Maybe some of you recall my name from OWTF, which is Nova's flagship project. It's the offensive web testing framework. If you are interested or you do web app assessments and you want to send some pull requests, right, or raise some bugs, just go to owtf.org, just type that in your browser, takes you to the OS page, and you can try. So now Fabian will tell us how all this happened.
Hey. So this whole project started by OpenNet Korea. They are a digital rights and privacy activist group in Korea. And they obviously heard that this law got introduced and they were very concerned. So they raised the awareness about this new law to Citizen Lab. And Citizen Lab is part of the University of Toronto, and they have every year a conference where they talk about global issues on surveillance and privacy and all the topics that fall into that kind of category. So OpenNet Korea told about this law, Citizen Lab, and Citizen Lab started then working on analyzing the technical implication and the privacy and maybe surveillance issues that come with this new law and those applications. So they started that, and then we joined as technical researchers doing the reverse engineering and the technical analysis of these applications. And that was partially then also funded by the Open Technology Fund. So we are talking about South Korea, just in case to remove any misconceptions. We are talking about not North Korea, but South Korea. South Korea is a very interesting country. If you look at the survey that I found, you can see that basically if you look at the smartphone usage of the total population, you're basically at almost 90%. And if you compare that to countries here in Europe, we just barely make maybe 70%, and Germany is, for example, just at 60%. While if you even look at young adults between 18 and 34 years old, they are basically 100% smartphone usage. And again, if you compare that to Europe, we are not there. So you can see that smartphones are extremely important and widespread everywhere. And you can also imagine that a lot of children are using these applications and smartphones everywhere. And they have similar concerns that we have here in the West and that our politicians are discussing about the risks online. So they proposed and implemented a law that they are saying that mobile operators have to provide adult content filtering measurements if they want to do business with minors. So if you're a parent and you want to buy a phone for your child, the mobile operator has to provide some means of control and blocking for your parent. So that was a law introduced late 2014, still very vague what that means. In the beginning of start of 2015, they added some more implementation details, still very vague, still not like technically detailed what it is about, but at least we are getting somewhere. But what we do know is how what the practical result of this became. And the practical result of it was basically that you had an application that was mandatory installed on the phones of children and their parents when they want to buy a phone. And that's an interesting ad tech vector if suddenly a whole country or the children have to have an app installed. and the law doesn't see an opt-out of it. So the law states that these measures, these features have to be there, and so even if a parent doesn't want to use it, the application is still there. Again, very interesting attack vector if you want to harm somebody. And here's a picture of a mobile store where a poster where they're informing the public about this new law. They're saying here that they have to provide this blocking and an app has to be installed on the phone and some details about the law, these vague implementation details I mentioned before. And this all resulted in the Korean government funding a company to develop the go-to application, which was Smart Sheriff. So they gave basically a company called Moiba, Mobile Internet Association, $2.7 million to develop this application. And if you see this amount, and you will just soon hear about the implementation flaws of that, it's a bit scary how much money was spent on it. So Moiba developed actually two applications. One is Smart Sheriff and one is Smart Dream. And Smart Sheriff is the one that is actually the mandatory one by law. This is the go-to application. That is the application that is supported, funded, or paid by the government. So this is the application everybody was basically using at the time. But they also have a second application called Smart Dream, which is an additional service they offer, which you will later see is very close together to Smart Sheriff, so parents might choose to use it too, and we also had a look at that one as well. Now, I mentioned that mobile operators have to provide such blocking features, so they started to develop their own applications, and here are the three big mobile operators in Korea that offer their own application now, but they were not used much. Smart Sheriff was the go-to application, but they become now more and more important because Smart Sheriff has so many issues. Okay, so Abe will now talk a little bit about what we found.
So to understand how this works, this is basically a parent controlling the usage of the phone from the child, right? So Smart Sheriff has two operating modes. Like when you first install it, you choose if you are a parent or if you are a child. So this gives the parent, to the parent it shows like an interface to manage like the usage of the child, and to the child it's just like blocking things, right? So just to give you an idea, some of the things that you can do as a parent is to block phone usage some times of the day. Like for example, you are not allowed to use the phone during the night or something like this. Or you cannot use the phone when I know like you should be like at school, things like this. So deny phone access for certain times of the day. Another thing that you can do as a parent is to see all the applications that are installed on the phone, and then you can enable them or not. So you can say, well, you cannot use KakaoTalk, which is a very popular like IM application in South Korea, or things like this. So the parent gets control to this, and then another thing that parents can do, but wasn't fully implemented when we tested this, is website management to control like what websites is the child visiting, and to be able to block some websites or not. So that's the capabilities that a parent has. So just to give like a comparison of impact, because we are going to talk about Smart Dream afterwards as well. So Smart Sheriff has the family association, so you know like which phone number is the child, which phone number is the parent. There's the association, like who is the parent of who. There's the children's names, birthdays, installed applications, uses statistics, and then there's the visited sites and blocked URLs. But Smart Dream is a little bit more sensitive because it also has like SMS messages and KakaoTalk messages. So what children are typing is like stored on a server for this kind of stuff, and that is a little bit more scary. So let's talk a bit about the problems that we had at the beginning, right? Like, because like Korean is such a beautiful language, but as a European, like without knowing really like Korean, when you're trying to test an application like this, you have like buttons with all these beautiful symbols, but you have like no idea like what that is supposed to do and all this, right? So that was one of the first challenges at the beginning, like to know what is the attack surface of the application and be able to browse all this. So how many of you have some Android reversing background? Anybody? Nobody has Android reversing background? Okay, some. So for the ones that don't have too much of an Android reversing background, there's a very popular tool for these kind of things that is called APK tool. You have the link there, but if you Google it, it's probably the first result. So Android applications are packed in a file that's called an APK. So what APK tool lets you do is it lets you decompile the application into an intermediate language, which is called like Smiley, and then there's some files like the strings.xml normally has like all the messages in beautiful Korean. So we took this, we Google Translate everything, got the new strings XML in English, and then pack it again, create a new APK with all the messages in English, and then we were able to see all those buttons in English. But then this was not enough because the application, of course, also makes requests to a backend that then sends like the data in Korean to show it on a web view, right? So for this, like sometimes we had to like stop with burp, you know, like stop the request, the response, and then just Google Translate it, and then put it back, and then see it on the app, and then from there, like keep using the app and try to identify all the attack surface. So that's one of the other things that we had to do. And then as you decompile, you can also make changes on the application. So we also like added, like this is the Java code. So you can like add some log messages to know like am I really reaching this code or not, like as I'm tapping on buttons and things, just to be able to debug the application better. So we also like added some debugging messages. So after all this, we were like ready to start. And the first issue that we found was remote code execution in a web view. So in Android, from Android 2.4 to Android 4.1, there was a bug that if you have a JavaScript interface, you could get remote code execution on the phone. So a JavaScript interface basically lets you, from JavaScript, to invoke Java classes and stuff. But in those Android versions, that could also lead to remote code execution. Now, why do you think this is remote code execution? Any guesses? Anybody? Nobody? What is wrong with this, apart from the JavaScript interface? Don't you see anything wrong here? SSL. That's it. So this JavaScript interface is an issue because there's no SSL. So anybody can, like a bad guy can be like in a coffee shop wearing a mask like this, waiting for all the children to go for the free Wi-Fi, like after school. And then they can get remote code execution on the phone, just changing the traffic because it's all in the clear, so you can change all the traffic and make the JavaScript interface exploit this Android bug. And you get remote code execution on the phone. So that was one of the first findings. And yeah, we pen tested this twice. So just to save a bit of time, and we can cover the apps later, we are going to fast forward to the fixes of each of the findings so you can see how they fixed each thing, which is going to be also funny, hopefully. So like the first reaction, like when we were testing it for the second time is, well, it looks like they're using SSL, so, you know, in principle, it's looking better. But then we found that, like on Android, you can override the APIs for when there's like SSL errors or the host name doesn't match the certificate and stuff like this. So this is the code, actually fits in one slide. That's all the code there was. So if there's an SSL error, proceed. And if the hostname verifier, you know, if the hostname doesn't really match the certificate, just return true. So this is basically, you know, accepting all the certificates, no problem, right? So self-signed certificate, so anybody can still like man in the middle of everything and exploit the bug that we talked about before and see all the traffic, and the phone is not going to complain because it's written like this, the application, right? So we found that it was like really funny. And now, this is another thing, right? Like maybe they thought, well, maybe SSL is not necessary if you like encrypt the sensitive parts of the request, right? So maybe they were thinking like this. So this is the unencrypted phone number. This is the encrypted one. Any guesses about the algorithm? Anybody? So this was doing an XOR with, this is what you see at the top is the key. And XOR is cool because you can like use it for encryption and decryption, so you only have to write one function. It always saves a bit of time. So yeah, so basically they have this hard-coded key on the APK. So anybody that reverses the APK can see the key. And to their credit, there were some null characters here. So maybe like if somebody like runs the strings command on the APK, maybe you wouldn't find the key. But of course, that's not very helpful if the application is written in Java, right? So, so yeah, so anybody can like read the key from the APK, and then you can like encrypt and decrypt like them, which we built a Python script for. So that's that. So now let's look at how this stuff was fixed. So they added even more crypto later. So there's a new hard-coded key on the APK, and then this is the JSON that is sent to the server, right? And then this is like encrypted with AES, and then it's base64 encoded, and then this is what is sent to the server. It's completely useless because it's just another hard-coded key on the APK, right? So just to summarize, you have one APK with two hard-coded keys now. So this is the phone number. You XOR with the first hard-coded key on the APK, then you get this. Then this is all the JSON. You do the AES of that with the second hard-coded key on the APK, which anybody can get as well. So all this is completely useless. Then all this request is sent through the SSL that I explained before is going to accept all the self-signed certificates and everything. It's just proceed and return true, that I explained before. So that goes through the fail SSL layer, and then the server just responds like this. So it's just, you know, like a design of fail, I don't know. So it was like funny to put it in a slide like this, right? So now let me tell you a story, right? Like let's pretend that there's a child in the class, right? Because this is like all about protecting the children. So let's protect this child in the class that is really mean. He wants to make the life of all the other children in the class like miserable, right? Like he wants to make them cry, he wants to make them suffer. So thanks to this Smart Sheriff API, he has like some potential here, right? So, I mean, and in life in general, like you should always ask questions. Like, what can happen? Like, the only things that can happen is that maybe you don't get an answer, or maybe you get a different answer than the one that you were hoping for. But when you ask questions, amazing things happen, and this is a great example of that. So you say, Smart Sheriff, I really want to screw with this child. I want to mess with him. And you ask that to the Smart Sheriff API, and then the Smart Sheriff API tells you, sure, this is the parent phone number. Now this is already bad enough. I mean, you can do some damage knowing somebody's parent phone number, but as a mean child, you still have the password left, right? Because you can log in with the parent phone number, but you still need the password. So you can just ask politely, like, can you give me the password, Smart Sheriff? Like, come on. Of course, Smart Sheriff also gives you the password of the parent. So this mean child can, the password is using the XOR stuff. But because the key is like hard-coded on the APK, you can like decrypt it, so it's easy. And yeah, and then you get parent access to control the phone of the child. And what does that mean? That you can say, well, this child cannot use the phone like 24 hours a day, like all the applications are forbidden, you know, and just, you know, all the websites are blocked and all that kind of access. So you can really like screw with the life of a child with this. So yeah, like technically this is how it looked like. So you make a curl request with the mobile phone number doing the XOR stuff. And then this gave you like the password with the XOR stuff and the parent phone number. So yeah, this is the encrypted and decrypted and encrypted and decrypted. So that's it. So it's interesting, right? And then, yeah, the other thing is there were no brute force mechanisms, so anti-brute force mechanisms, and it's just tapping of 4 digits. So, I mean, it's just 10,000 tries and you are in, right? But anyway, like there's so many users that you can just keep trying, right? So you can just keep trying because the application is mandatory in South Korea. So this is a script that we wrote for this. Oh, well, this is a script that we wrote for this, so it's just trying like phone numbers at random, and like there's so many users that it just keeps like finding numbers and then of random like parents and children and gives you like the password of the parent. So you can just keep doing it like this. Where do you? easier to see there. So you can see there like a new child has been found, and then you get the parent phone number and the password for the parent. It's just such a mess, right? Like you can like get all the children and the parents and the password of the parents for every child in the country. It's just so messed up. So yeah. Another potential application for children that want to mess with other children is to fake the usage. So you can, for example, pretend that the child that you want to mess with is like searching for porn or has installed a porn application or something like this, so that this child, like when he goes home, he's going to have a difficult conversation with his parents, right? Like, what were you doing with the phone, you know, and all that kind of stuff. So it's also interesting for the bully, like this feature, right? So essentially, like no authentication for the application. There's a device ID as a session cookie. But I mean, even in our examples in the report, like because it didn't matter what you put on the device ID, even in the proof of concept, it was like whatever, you know, like the word whatever, and it just worked anyway. So it's, yeah, I mean, it was just with the phone number, it was working fine. So yeah. Now let's look at how they fixed this. So on the second test, you could still ask the Smart Sheriff API. It still gave you the parent phone number for the child, so that was not fixed. And then when we asked for the password, we got this asterisk. But it's really funny because, like in our report, we were using curl for to demonstrate the issue. Like if you send this curl request, then you know this happens. So if you change the user agent in 2 or 3 of the endpoints, if you change the user agent to, I don't know, Chrome or Firefox or something, it still gave you the password, like in clear text. It was like so funny. Like you change the user agent and it still works. But yeah, then that was later fixed, but it was just ridiculous that changing the user agent still gave you a password. And yeah, this was also not fixed, so you can still like fake the phone usage of a child, pretending that the child is doing stuff. And then we found excesses on the first test, and that one was fixed, but on the second test we found another one. And now, to understand the demo now, because some of our reports are public when we can, you know that they can be indexed by Google, right? So what happened is that if you search by the domain of Moiba, because our report has been indexed, the proof of concept for the XSS is indexed by Google, so you can click on the result and you get the alert. So the proof of concept still works, and Google has found it and indexed it, so you just search for Moiba and you get it, and here you can see like where the alert is here on the, in a script context, how it works. It's just so funny, like you really like fucked up hard, like when even Google has your vulnerabilities, right? So yeah, and then this section is called "Why Not?" because I mean we were like showing shock that this is so broken. Like we were like joking, like, well, why not? Like you can do it like that if you want to, right? Why not? So this "Why Not" ran like Tomcat 6.0.29, which was released 7 years ago to protect the children. I mean, why not? Have a backend that is this old and this out of date to protect the children. Like why not? Then this was the web filtering. So we found a web filtering bypass. The interesting part is here on the filter. So if it does not contain this, then it will be blocked, right? So you can just add a fake parameter containing that on any blocked website, and then you are in. So this was really funny as well, just way to bypass the web filter. Other things that we found in Android, like the internal storage is supposed to protect like sensitive stuff so that other apps cannot read it. So you have here the Smart Sheriff database on the application storage, and then this was like, it was saving it on the SD card, like when every application can read it. And if you punch a child on the face and get the SD card out, you can also read the database without knowing the PIN for the phone or anything. So yeah. Lots of things like this, even unlicensed funds, right? Like remember, like at the beginning, $2.7 million, right, for this, and using when we're looking at the burp traffic, this font is made with the trial version of Font Creator. You may not use this font for commercial purposes, right? Or an application that the Korean government has given 2.6 million. So it's just And development snippets everywhere. Lots of lots of stuff. Internal URLs. We found phones for testing passwords for test users, test development servers, internal paths to stuff. I don't know, lots of things. So in summary, just a big pile of poo. So we found XSS, leaking personal data over the API, no authentication, no transport security, even a SQL injection on the mobile app, and just don't take our word for it. These reports are public, so you can just go there and read them for yourself and see the proof. And now Fabian will tell us what happened after that.
So we created our technical report and we gave it to Citizen Lab, and Citizen Lab published a report with the title, "Are the Kids All Right?" and asking the question, does this application really protect them or put them in more danger? So Moiba reacted to that and they released press releases. No word about the issues we found. Basically they were just saying, oh look, we work on our security and we have now SSL, and you have seen how they implemented the SSL. Other press release after the second round, again, like no word that there were actual issues, but there was a small success. They said they would deprecate the old API, which makes sense because it's so horribly broken, the whole design is flawed, they basically have to start over to make it right the next time. So that was quite positive. It also got some media attention, but the public outcry that Citizen Lab and OpenNet Korea were hoping for didn't happen. And basically they were just all silent and ignored a lot. And we kind of felt as researchers that we just gave Moiba a free penetration test and this whole thing backfired. Instead of getting rid of this application, getting rid of this law and taking this whole thing down, we kind of felt like we just improved their security and now they just keep going with that. And we reported things like filter bypasses, which would be great for the children to use, and now we fixed those as well. So we felt like we improved something that we didn't want to improve. So then Citizen Lab published a second report after our second round of pen test, asking the question if they are still at risk, after Moiba fixed their stuff. And the response to that was surprisingly that Moiba said that they now remove Smart Sheriff and that you please move to other blocking services. A little bit of whiny blog post that they offer free services for such a long time and whatever. But yeah, they say now please move to other services, we are getting rid of this. And news hit, we read Smart Sheriff disappeared, and we were super excited and stoked about this. We felt like, okay, now we have won. Like the second test has shown them that they can't get the security fixed, and they came to their senses in getting rid of this and maybe making a new thing in the future, but for now we were saving all these children, basically. That's how we felt. But then we realized something shady was happening. And you see here a note edit in the Citizen Lab report, and they are saying that Moiba removed the Smart Sheriff application from the Play Store. However, the Smart Sheriff API remains still available. Okay, well, give them some time to deprecate everything and throw everything out, that's fine. But additionally, Moiba appears to have republished Smart Sheriff under another name, Cyber Safety Zone, on the Play Store, and it looks very similar. So we asked, did we fail with this? This is a screenshot from a Korean alternative app store, which is very popular there. And you can see here a different logo, different name, Cyber Safety Zone or Cyber Relief Zone, depending on how Google Translate feels that day. But you can see that the pictures look very similar to how Smart Sheriff looks like. So here a little game, try to find the differences between those two applications. Here's Smart Sheriff and the new one, Cyber Safety Zone. The logo changed and a little bit of text changed, but okay, it's clearly the same thing. And also while researching for this talk, I visited the website a lot, and this is the old website with the Smart Sheriff logo and Smart Sheriff everywhere, but it disappeared. You can see here the web archive picture from it. This is how the new Moiba website looks like. Names changed, logos changed, completely redesigned. Also, I think this is kind of creepy if you think about it, like the children being happy family, but it kind of also looks like the dad is like trying to control all the hobbies of the child, maybe, I don't know. But one good thing is here's a press release from the beginning of the year where they increased the PIN from 4 digits to I think 6 or 9 digits or something. So I guess that's something. Then also, if you look, they have now a web interface for the parents, so not only the phone app, and if you compare the capabilities of the web interface, it's exactly the same: time management, application management, and website management. So they are the same thing. So we can summarize, yeah, Moiba never deprecated the API, as they said they would. Moiba simply renamed the application and redesigned it. And apparently, I guess that's my interpretation of this, they tried to hide the bad issues. So, but what's up with Smart Dream? Because that's a second application, and we were kind of like, it was itching us, like, what is up with Smart Dream if Smart Sheriff is already this horrible? So we had a look at that one as well. It makes also sense to look at it because this is the login screen for Moiba. You can see Smart Dream and Smart Sheriff very close together, basically same login interface, and they are actually just the same form. They just make it easy, I guess, for non-technical parents to understand what they are logging in for. Anyway, Smart Dream also comes in two modes. On the parent phone, the parent can observe messages and Google searches that the child has done if they contain harmful words. And on the child mode, it just monitors the SMS messages and KakaoTalk messages in the background. And KakaoTalk is an instant messenger in Korea that is very popular. And it installs, and the interesting and very clever thing, I have to give them that, I haven't thought about it this way, but I was asking how do they get access to the Google search terms and the KakaoTalk messages, because that is a third-party application. How do they get access to that? And they install themselves or request the accessibility permissions. And accessibility permissions on Android allow you to develop an application that you can use for text-to-speech if you have vision impairment or something like this. So they abuse this to get access to text areas in different applications to extract this information. And that's quite clever, actually. And you can have then also a web interface for Smart Dream where you can look at these applications. So here's how the parent would see it, like my child received a phone number from here, and here are two test messages. And on the web backend, it would look the same, like at this time from this number. And here, back there are my test content messages. And if you're a web security guy, you can guess why the H1 is so big. Does anybody know? Well, it's obviously also vulnerable to XSS here, so you can just like send your friend an SMS with a cross-site scripting payload in it, and when the parent opens and sees your message, they get XSS'd. And the crazy thing is also that, like Smart Dream, there was no authentication. So I could just push this XSS payload to every parent that is using this application, and I can XSS them all. And that's a bit crazy. They also had, when you try to register, which is important for us as researchers, they try to check your phone number with an SMS verification code, but the check was done in JavaScript, so you can just like ignore that and just bypass and register anyway. They fixed that, but if you install the application, you can still register on the phone, it still works, so that is like meaningless protection. But the most scary thing is that this application in the server stores more than, at the time of when I test this, 700,000 messages of more than 55,000 children. And I know this because I know these numbers because when I was testing, I saw that my test messages and my test children that I created just simply incremented a counter. So every child I added was just +1. And so I assumed, okay, that is how many messages there are already on the system. And then I tried out these APIs and attempted to just like, let me see if I can access to the messages of child with that ID. And you can see here a test program I wrote that just like dumps all the messages for a certain, like just iterating over all the child IDs and the child messages. And you can just dump all the private messages and Google searches that are stored by the servers. So these messages are here, not real. I replaced the real Korean letters with just random other ones to protect their privacy. But it's really scary to see that everybody can just simply dump all these very private messages. But as I mentioned, they try to store only messages that contain harmful words. And so here's probably our most offensive slide, because that one contains the over 1,000 harmful words that are monitored by Smart Dream. So let's have a look at what these harmful words are that are so important to yeah, you read for yourself. divorced single parent. I think that's very troublesome for children that have family issues at home, that the parents get notified by it. Or even things like Black history or multiculturalism are words considered noteworthy to be, the parent to be notified that the child is searching for this online or something like this. And also just like word snippets like guy I like, girl I like, or I hate da-da-da, boyfriend, girlfriend, all these extremely personal things. And or here for young women, menstruation, like children that search for something like this, so private, and parents get notified by it. Very troublesome, at least for me. But Moiba learned, and that was interesting, that after we first disclosed the first reports for Smart Sheriff, they were in denial and were threatening with lawyers, like the typical stages of a company that never received a security report before. But now they are actually really nice to work with. So they actually responded with an Excel sheet saying, look, these are the issues, and here's how we propose to fix them. And that was quite positive, that this change of tone with them, that they actually saw some benefit with working with security researchers. Not to mention that their proposed fixes are a bit ridiculous, and they're showing that they don't really understand what the issues are. But I mean, I think it's positive that they don't threaten immediately anymore. So, for example, for the lack of authentication, they proposed they just use more encryption. We have seen how they do encryption. That doesn't make any sense. The hard-coded API key that this application had, they said they would put it into a binary. That doesn't matter much. I can just reverse the binary, or I just intercept the request again and just read the key there. But in the second step, they want to get each user their own key, which might also automatically solve authentication. But just seeing that they don't really understand that these things belong together and might fix each other. Or with the XSS messages, they were proposing to escape and replace special characters before they are sending it to the server. Well, that doesn't matter much if I just fake these requests and send the XSS payload myself. So that doesn't really help much. It just shows their non-understanding of these issues. Again, we have a big pile of poo, XSS, no SSL as well, lack of authentication and authorization for accessing all these messages, and everybody can access and dump these messages, which is quite scary. But also, what about the other alternative applications from the alternative mobile operators? It turns out that 2 of them are actually by a third party called Plantinet, so that company developed basically both of them. And so we only had to look at one of them. And there was even a personal message embedded in one of the Java classes inside of the application dedicated to us. Damn you hacker, what is your benefit when decompile this app? Please don't disturb us. So we felt very loved by them. But pose the question, why do they include this? What are they scared of we are finding in there? And I don't want to even say what you see here, just look at this and think about what they don't want us to find in this application that could possibly lead us for finding this. And yeah, and the files get bigger and bigger. And so the other one from SK Telecom was more interesting because that one was obfuscated, was attempted to make our lives hard. And I just want to give you 2 ways how we defeated the obfuscation and encryption of this application. The first one is the lame strategy. This is what I did. I just created my own test application and loaded the binary that is doing the encryption myself, exposed the encrypt and decrypt functions, and just call decrypt on all their obfuscated functions. So I could get all the clear text of everything. That's how I defeated it. But the way cooler way, and Jeff from Citizen Lab did that, he really reverse engineered the binary, reverse engineered the obfuscation algorithm, and wrote a Python script to just simply decode all the obfuscated strings. So 2 approaches on how to defeat obfuscation. Both lead to the same goal, but different approaches. So again, another proof showing that obfuscation encryption doesn't really matter much. Slowed us down a little bit, but now we have the script. Now any app obfuscated with this is defeated, so it doesn't matter. And there we also found no HTTPS, XSS everywhere, so it's horrible. We have not too many details about it yet because we still haven't really disclosed that to them, or at least they ignored us, so who knows what's coming there. Okay, now a note for reflection.
Yeah, I want to ask something
very difficult for you. So after all this stuff that we
Excuse me, the microphone.
Better? Yeah. So just make an effort and, just imagine, pretend that all these applications were perfectly secure. Like, would you trust any company or government to have all this information, right? And on this information is like the phone usage statistics, like when a child uses a phone, the applications that they're using, the SMS messages, the IM messages, knowing family associations, names and birthdays. Like, would you trust any company or government to have a database with all this information? So yeah, so the concept is flawed by design, right? Like, you cannot make something that is opt-in for everybody and doing this. So now Fabian will.
So what is happening next? The Korean government actually proposed an update to this bill because they are concerned, obviously, as well. And their first proposal is now that there's an opt-out, that parents are not forced anymore to install these applications. They are offered features, but they don't have to use it, which is a first good step, but also kind of takes away the argument of OpenNet Korea, who would like to see this whole law be removed completely. OpenNet Korea also filed a constitutional complaint about this law, but a result is expected in 2 to 3 years, so that will take a little bit of time. And they are also asking the question, what did go wrong here? Because such an application could also be implemented differently without a central server, with locally just some child protect mechanism to don't allow certain times the phone is used. That doesn't really require storing all the sensitive data at a company's central server. So something went wrong there from the beginning, and they are thinking about, can we make a regulation, a checklist that has to be fulfilled by companies that offer services like this to just have a certain level of quality and protection for the people that are using them. So they are thinking about this. If you know some regulations or information about this, that would be nice to get to hear about that. Otherwise, here are some reports from us you can find online and some news articles. You can just check out the slides afterwards. And otherwise, do you have any questions, comments, or discussion about it? Thank you. Any questions?
Yeah.
It's more of a statement. Basically, I don't know, have you been living in Korea?
So the question, I have not been living in Korea.
I recommend it in that discussion because the cultures are very, very different.
Yeah. So
that's something to consider. So also when you want to achieve something, some security improvement, I recommend getting in contact with somebody who understands the culture there in order to get it done. Because if you just shame people, this is really bad.
Yeah. So he is saying, giving a statement that asking if I have lived in Korea, and I obviously haven't, and I should get in contact with people from there to actually get change done. Yeah, absolutely. So OpenNet Korea are Koreans. They are doing this work. We just did the technical research, and they are using these reports and are in contact with the government. As you said correctly, I am just an outsider living in a completely different culture. I have talked to many Koreans over this, and they shrugged. It's different for them. They have a different view about this, and they don't see a big issue with that. That's also why there was no public outcry, as Westerners in the US and here in Europe were hoping for. And OpenNet Korea are Koreans. They are working there trying to make change. But I understand that. Yeah.
Because you wouldn't get it done.
Yeah.
They initiated this. That's what we tried to explain at the beginning. OpenNet Korea were the ones that initiated this, brought it to the Citizen Lab, and then the first time started because of them. Yeah.
So about the shaming part, yeah, I agree. It's for us. We are just technical people. I'm just having a little bit of fun now. But I see that it's problematic.